Imagine a place where rain evaporates before it hits the ground, never even touching the surface. It's not science fiction, it's a reality on Venus, our neighboring planet. But this isn't a gentle rain. It's sulfuric acid, a corrosive substance that would dissolve anything in its path. Acids, extreme heat, and crushing atmospheric pressure. These are just a few of the formidable obstacles life would face in our solar system's most toxic environments. The search for life beyond Earth is an exciting and ongoing quest, but it's equally important to understand where life is impossible, where conditions are too harsh for any known organism to survive. These places, often deemed hostile, hold crucial clues to the universe's formation and the delicate balance that makes life on Earth possible. Our solar system, a fascinating collection of planets, moons, and asteroids, showcases a wide range of environments. Some, like Earth, are teeming with life, with lush landscapes and diverse ecosystems. Others, however, are so extreme and inhospitable that even the hardiest organisms known to science wouldn't stand a chance of survival. So, where in our vast cosmic neighborhood is life most unwelcome, where conditions are the harshest? Let's embark on a journey to uncover the most toxic and uninhabitable places in our solar system, where life simply can't tread. The answer, perhaps surprisingly, is closer than we might think. It's not on a distant, icy moon or within the swirling clouds of a gas giant. The most toxic place in our solar system is our closest planetary neighbor, Venus. Often dubbed Earth's evil twin, Venus might seem inviting from afar. It's similar in size and mass to our planet. But look closer, and the resemblance ends there. Venus is a hellscape, shrouded in a thick, toxic atmosphere. A human on Venus wouldn't just have a bad day, they'd cease to exist within seconds. The conditions are beyond extreme, making survival impossible. The atmospheric pressure is 90 times that of Earth's equivalent to being 3,000 feet beneath the ocean's surface. Imagine the crushing force enough to flatten a submarine. Then there's the heat. Venus boasts an average temperature of 900 degrees Fahrenheit, 475 degrees Celsius, hot enough to melt lead. This relentless heat would incinerate any human-made object. This extreme temperature is due to a runaway greenhouse effect. Carbon dioxide, the main component of Venus's atmosphere, traps heat from the sun. The planet becomes a pressure cooker with no escape from the heat. And let's not forget the rain. Venus's clouds are laced with sulfuric acid, a highly corrosive substance. This acid rain is deadly, capable of dissolving metals. Luckily, this rain evaporates before it reaches the surface. But it adds another layer of hostility to this already extreme environment. The combination of pressure, heat, and acid makes Venus a true hellscape. Section 4. The solar system's poisonous roster. While Venus holds the crown for toxicity, other contenders deserve a dishonorable mention. Jupiter's moon, Io, is a volcanic nightmare. Its surface is a chaotic landscape of erupting volcanoes spewing sulfurous gases. Saturn's moon, Titan, might seem more hospitable with its thick atmosphere and methane lakes. But with a surface temperature of -290 degrees Fahrenheit, life as we know it would struggle to survive. Even Mars, a planet we hope to one day colonize, presents significant challenges. Its thin atmosphere offers little protection from radiation, and the lack of a global magnetic field leaves its surface exposed to the sun's harmful rays. Section 5. Unveiling the universe. Lessons from toxicity. Why study these toxic environments? What can they possibly teach us? Because in their starkness, they teach us about the fragility of life and the specific conditions that make a planet habitable. They reveal the fine line between a thriving ecosystem and a barren wasteland. By understanding what makes a planet inhospitable, we gain a deeper appreciation for the delicate balance that allows life to flourish on Earth. This knowledge underscores the importance of preserving our own planet's environment. Studying toxic environments also provides insights into the early solar system. These harsh conditions can mirror the primordial states of planets, offering a glimpse into their evolutionary paths. Venus, for example, may have once been a more temperate world. Its current state of extreme toxicity serves as a cautionary tale. Understanding its descent into toxicity could help us predict the fate of other planets and safeguard the future of our own. This knowledge is crucial for developing strategies to protect Earth. These extreme environments, though seemingly devoid of life, are far from lifeless in scientific value. They are rich with data that can unlock many cosmic secrets. They are cosmic laboratories that hold clues to the universe's past, present, and future. Each toxic environment is a chapter in the grand story of the cosmos. By venturing into these toxic realms, we embark on a journey of discovery that illuminates not only the cosmos, but also our place within it. This exploration helps us understand the broader narrative of life and existence.